In this video, we're going to talk about extreme values of functions. Let's talk about definition of absolute extreme values. Let f be a function with domain D, then f of c is the absolute maximum value on D if and only if f of c is the highest y value within that domain. An absolute minimum value on D if and only if f of c is the lowest y value in that domain. And sometimes instead of absolute value, we could use the word global. Also, note that absolute maximum value and absolute minimum value refer to y values of functions. Let's take a look at some example. If you look at the graph of cosine x from the domain negative pi over 2 to pi over 2, that is a graph of cosine x. So what will be the absolute or global maximum value? So within the domain of negative pi over 2 to pi over 2, the highest y value occurs at when x equals 0. And what is the y value? It's 1. Therefore, the answer is 1. Absolute maximum value will be 1. What about absolute or global minimum value? What will be the lowest y value of cosine x within that domain? It's going to be 0. And it occurs at the when x equals negative pi over 2 and pi over 2. So the absolute minimum value is 0. What about the graph of y equals sine x from negative pi over 2 to pi over 2? What will be the absolute maximum value? Well, the highest y value occurs at when x equals pi over 2, and the y value is 1, so the absolute maximum value is 1. What about the absolute minimum value? The lowest y value is negative 1 within that domain, so it will be negative 1. And notice the interval is closed. So we could include the negative pi over 2 and pi over 2. Now what if we have y equals x squared and the domain is negative infinity to infinity? This is how the graph of y equals x squared will look like. Now, do we have absolute maximum value? What is the highest y value? We don't have it because it keeps on increasing. So there is no absolute maximum value when the domain is negative infinity to infinity for y equals x squared. What about absolute minimum value? What is the lowest y value? It is 0, and it happens when x equals 0. So the absolute minimum value is 0. Remember, absolute maximum and minimum has to do with the y values of a function. Now, what about they change the domain to 0 to 2, including the endpoints? So this is how the graph will look like. What is the absolute maximum value? The highest y value is going to be 4, which occurs at when x equals 2. So maximum value is 4. What about the absolute minimum value? What is the lowest y value within that domain? It's going to be 0, which occurs when x equals 0. What about the domain is 0 to 2? And this time we're not including the 0. It's open at 0, but it's closed at 2. What will be the absolute maximum value? The highest y value occurs at x equals 2, and then the value of y is 4. So the absolute maximum value will be 4. What about absolute minimum value? The lowest y value. What is the lowest value? It doesn't exist because it's open at 0. We don't have any absolute minimum value. What if now they're both open? So you're not including 0 or 2. What will be the absolute maximum value? In this case, the absolute maximum value does not exist because we do not have a highest y value within that domain. Just think about it. As you get closer to 2, right? What is the highest y value you're approaching? I mean, you're going to get closer to 4, but you don't actually get there. You could say 3.9, 3.999, 3.9999, and so forth. So we don't have any absolute maximum value. For the same reason, we don't have any absolute minimum value. The extreme value theorem says if f is continuous on a closed interval a to b, notice the word closed interval, it includes both a and b, then f has both a maximum value and a minimum value on the interval. So let's take a look at some examples. So we're stating that both a and b are closed. In this interval, or on this interval, the maximum, which is represented by capital M, and the absolute minimum, which is represented by lowercase m, it happens at the interior points of A and B. The absolute maximum happens at over here, and the absolute minimum occurs at over here. However, in this case, where the function is decreasing, the absolute maximum happens at A, at the endpoint, and the absolute minimum happens at B, which is also at the endpoint. In this case, the absolute maximum happens over here, which is the interior point, but the absolute minimum happens at A, which is at the endpoint. What about this one? The absolute minimum will happen over here, which is the interior point, but the absolute maximum happens at the endpoint. So depending on the graph, either absolute maximum or minimum could happen at the endpoint or interior point. But extreme value theorem states that as long as the interval is closed, there will be absolute maximum value and absolute minimum value. And we need to talk about local extreme values. Another word for local is relative. So when you see the word relative extreme value, that means they're talking about local. The main difference between absolute and local or relative is that local or relative represents the around that neighborhood. In that neighborhood, local maximum is the highest y value, and local minimum value is the lowest y value in that neighborhood. And I'm going to give you some examples. Let's take a look at this graph, y equals f of x. This is the y equals f of x. And we have an interval from a to b, and they're both closed. What's happening over here? Well, that is the lowest y value, so that is the absolute minimum. Also, around that neighborhood, that has the lowest y value, so it could also be a local minimum. What about over here? Well, we know that that's not the absolute maximum, because that doesn't give you the highest y value. But around that neighborhood, that is the highest y value, so we say that is a local maximum. And what about over here? Around this neighborhood, that gives you the lowest y value, but that's not the absolute minimum value, because absolute minimum value occurs over here. So we call that point right there the y value at when x equals e. That is a local minimum value. What about over here? Well, we know that that has the highest y value on the interval from a to b. So that is the absolute maximum. Also, around that neighborhood, that has the highest y value, so it could also be a local maximum. Now, what about over here at the endpoint? Well, we know that that's not the absolute maximum nor our minimum. However, around that neighborhood, that has the lowest y value, so we call that a local minimum. Again, local minimum and local maximum has to do with the y values. Also notice, whenever you have a local maximum inside the interval, interior point, what is the slope of this tangent line? It's going to be 0 because the line is horizontal. Over here, local minimum, the slope is going to be 0. What about at the maximum? Here, the slope is undefined. And theorem 2 says local extreme values. If a function f has a local maximum value, a local minimum value at an interior point C of its domain, and if f prime exists at C, then f prime of C has to equal to 0. And this value C, we call it a critical point. It's a point in the interior of the domain of function f at which f prime of equals 0 or f prime does not exist is a critical point of f. And we're going to look at some examples. So how do you find the critical number of this function? Well, you know that the critical numbers happen when f prime of C is equal to 0 or f prime of C does not exist. In order to solve for the critical numbers, find critical numbers, we need to find the derivative. So you get 3x squared minus 12x plus 9. So now what we need to do is set equal to 0 and then solve for x. Let's divide everything by 3. You get 0 equals x squared minus 4x plus 3. This is factorable. So you get x minus 3, x minus 1. Therefore, x is equal to 3 or x is equal to 1. Now, these two values, x equals 3 and x equals 1, make the derivative goes to 0. So we have two critical numbers here, x equals 3 and x equals 1. And let's find the critical number for this function. In order to do that, let's find the derivative. And you could use a quotient rule, but I would rewrite this as quantity x minus 2 to the negative 1. And let's find the derivative. You get negative quantity x minus 2 to the negative 2 times the derivative inside, which is just 1. And you get negative 1 over quantity x minus 2 to the second power. And in order to find the critical number, you have to set it equal to 0. Now, when you cross multiply, you end up getting 0 equals negative 1. This is false, which means that this will never go to 0. When is it undefined? When does f prime of C or f prime of x is undefined? It's undefined when x equals 2, because that makes the denominator goes to 0. So we have a critical number at x equals 2, because when x equals 2, the first derivative is undefined. It's asking you to find the absolute maximum and minimum values of f of x on this closed interval. So in order to do that, we need to find the critical point, because absolute max, absolute minimum could occur at critical point, interior, and also we have to check the endpoints. So first, let's find the derivative of f of x. We end up getting 2 over 3 x to the negative 1 over 3, which will be 2 over 3 cube root of x. Now, when does that go to 0? Well, you cross multiply, you end up getting 0 equals 2, and this is false, so therefore, first derivative will never equal to 0. Now, when is first derivative undefined? It's undefined when the denominator is 0 and denominator is 0 when x equals 0. So that is the only critical point we have. So absolute min, max, could occur either at x equals 0 or at the endpoints. So how do you find the value, absolute max and minimum values? What is the y value of the function? So what we need to do is we need to plug in find f of -2, f of 0, and f of 3. And what are the values? What is f of -2? That's going to be quantity -2 to the 2/3, which is cube root of quantity -2 squared, which is going to be 4. What about f of 0? That's going to be just 0 to the 2/3, which is 0. What about f of 3? It's going to be 3 to the 2/3, which is cube root of 9. Now, look at the y values. Which one has the highest y value? Well, it's cube root of 9. So the absolute maximum value is cube root of 9. It occurs when x equals 3. What about the absolute minimum value? Well, the lowest y value is 0. So the absolute minimum value is 0, and it occurs when x equals 0. Now let's find the absolute max and minimum values of f of x on the closed interval from 0 to 2. Again, we need to find the critical point, so let's find the derivative. 3x squared minus 12x plus 9, set it equal to 0. Divide everything by 3. You could factor this. So you get x equals 3 or x equals 1. And these are the critical points. And notice, this is defined everywhere, so you don't need to worry about when this is undefined. Now, take a look at when x equals 3. X equals 3 is not on the interval. So you have to reject this. So x equals 1, 0, and 2 are the x values where the absolute max and minimum could occur at. So we got to find f of 0, f of 1, and f of 2. You plug it into the original function here. What is f of 0? That's going to be 2. And what is f of 1? Instead of that, you plug in 1, and you'll get 6. What about f of 2? Instead of x, you plug in 2, and you will get 4. So this 6 is going to be our absolute max value, and 2 is going to be our absolute minimum value on this interval.